and welcome to the gas laws. First things we need to know really is, I'll go straight into it, is we need to understand that when we're doing gases we've got to be an absolute. So really the standard, the system international unit for temperature is Kelvin. Not Kevin, it's Kelvin with a K. Don't confuse it with kilogram. Capital K. So absolute zero is really where there's nothing moving. Nothing moving. And absolute zero is minus 273 degrees C. So when we're using gases, we've got to convert degrees C into Kelvin. And all you've got to do really is add on 273. Because absolute zero is 273. So if we had 50 degrees C to convert that into Kelvin, all we've got to do really is add 273. So in the examples I'm going to be doing in the next couple of videos, when you see 273, that just means I'm converting degrees C into Kelvin. So 50 plus 273 gives 323 Kelvin. So that's absolute temperature. We're also going to be using pressure. Pressure can be measured in bar. If you watch the weather forecast, you get millibar, barometers, or the standard unit we'll use is a Pascal. 1 Pascal is 10 to the 5 bar. Also, we can do pounds per square inch, so you'll know that as American, but we still use PSI. But the standard unit is a Pascal. Temperature is going to be measured in degrees C or K. Obviously, we'll convert it into K. And volume is cubic meters. So all the gas laws about really are what happens to pressure, what happens to temperature, and what happens to volume of gases when either one of these is changed. So if you keep the temperature constant or you heat things up, what happens to the pressure, what happens to the volume. So we're going to be using Pascal, but you'll also come across bar, so you may have to convert from bar into Pascal. So 1 bar is really 1 atmosphere. So at the moment you've got 1 bar pressure on your head, and it's quite easy. 1 bar is 1 times 10 to the 5 Pascal, or 1, 2, 3, 4, 5. So 1 bar is 1 times 10 to the 5 Pascal. So 2 bar is 2 times 10 to the 5 Pascal. 3.2 bar is 3.2 times 10 to the 5 Pascal. And 5.6 times 10 to the 5 Pascal is 5.6 bar. So that may seem quite trivial, but some people will forget to convert. So make sure you convert into Pascal when you're using the gas law formula. So the first one we use, there is one big one that we use, but there are quite a few small ones that add into that. So Mr. Boyle, Boyle's law, hence boiling water. So with Boyle's law, his law was the temperature of the gas is kept constant. So all he did was kept the temperature constant and see what would happen to pressure and volume when you changed either pressure or volume. So pressure times volume is a constant. So here's his law. So P1V1 is P2V2. And P1V1 just means the pressure and volume before anything is changed. And P2V2 is the pressure and volume after something is changed. So with this P1V1, so what would happen to the volume if you increase the pressure of the gas? The temperature is remained the same, so we can ignore the temperature. So say if we had P1 and V1 has got to equal P2 V2. So if you increase the volume of the gas, if you double the volume of the gas, what would happen to the pressure? That's what Boyle's law was all about. So P1 V1 is the pressure and volume before a change, and P2 V2 is pressure and volume after the change. Bearing in mind we're only going to be changing one thing to see what happens to the other thing. So here's an example. So we've got a pressure of 3 megapascals, that's P1, and a volume of 0.7 cubic meters, that's V1. So we need to calculate the final volume, so V2, if the pressure is increased to 8 megapascals, P2, while the temperature remains constant. So we're keeping the temperature constant, so it's Boyle's law, and all we're increasing P2. So we know that P1 is 3 mega, V1 is 0.7, that's got to equal P2 V2, and we know P2 is 8, and we need to work out the final volume. So what happens to the volume of the gas when we increase the pressure? Boyle's law. So all I'm going to do now is bring the 8 down really. So V2 is going to be all of this, 3 times 10 to the 6 times 0.7, all divided by that 8 mega. And that will give me the volume after we increase the pressure. So if you increase the pressure, keep the temperature constant, this is what happens to the volume. The volume goes 0.2625 cubic meter. So if you increase the pressure, you bring the volume comes down, which makes a bit of sense, doesn't it, really, because you've got tighter volume, smaller volume, which means the pressure is going to go up. Temperature remains the same. So that's an example of Boyle's law. Charles's law, the pressure of the gas is constant, so we're keeping the pressure constant, but we're working out what happens to temperature and volume. But the pressure remains the same. So V over T now is constant. So V1 over T1 is V2 over T2. V1 T1 being volume and temperature before something changed. V2 T2 is the volume and temperature after something has changed. So Charles's law. So here's an example, a gas of volume 0.2 cubic meters, V1, and temperature of 25 degrees C is heated up to 100 degrees C. So that's the T2. Calculate the volume V2 after heating if the pressure is kept constant. So we know what V1 is, it's 0.2. We know what T1 is, it's going to be 25 plus 100. Sorry, 25 plus 273. We need to find what V2 is after we've heated it up to 100 degrees C. That'll have to be 100 plus 273. So we're keeping the pressure constant, so that's not changing, so we're going to use Charles's law. V1 over T1 equals V2 over T2. So we know V1, it's 0.2. We know T1, it's 25, but you've got to add the 273 to it. That equals V2, which we don't know, all over 100 degrees C plus 273, because we need it in Kelvin. So all I'm going to do now is I'm going to bring this 373 up here. So 0.2 times by 373, because 100 plus 273 is 373, all divided by 298, which is 25 plus 273, gives me V2. That gives me 0.25. So as we heat the gas up, keeping the pressure constant, but we're heating it up and it expands from 0.2 cubic meters to 0.25 cubic meters. That's an example of Charles's law, and this is the general gas equation. So really it's V1 T1 equals V2 T2 and P1 V1 equals P2 V2 all together. So it's the general gas equation is them all combined. So that's the one, you can just remember that one really. So P1 V1 over T1 equals P2 V2 over T2. So here's my example using this one. So we've got 0.1 cubic meters of gas is compressed from 200 kilopascals and 25 degrees C. So that's V1. This is going to be P1, 200 kilopascals, and T1 is going to be 25 plus 273, don't forget. So it's going from it's compressing from 200 kilopascals to 650 kilopascals. So we're squashing it, which means the pressure will go up. So P2 is going to be 650 kilopascals. The temperature is going to go to 85. We need to calculate the new volume after compression. So really, nothing's being kept constant. It's all changing. So we've got to use P1V1 over T1 equals P2V2 over T2. And we need to find V2. So P1 is here, look, 200 kilo. V1 is 0.1. T1 is 25 plus 273. All that's got to equal P2V2 over T2. P2 is 650 kilopascals. V2 we don't know, trying to find it, and T2 is 85 plus 273. So rearrange that a bit. So if you rearrange that, so what I've done here is now I've worked out this bit. So I've worked out all of that, because that's the number, and I put it there. 85 plus 273 is 358. So, and there's 650 times 10 to the 3. So 67.114. I'm going to bring this 358 up. So I brought the 358 up. So all of that equals 650 kilo over V2. I've then brought the 650 down. So 67.114 times by 358 gives you all of this, 24026. And then to leave the V2 there, as time is by, so I brought the 650 down. So all of this, 24026 divided by 650 kilo, gives me a volume of 0.037 cubic meters. So the volume of the gas when I compress it, and it comes to that temperature and that pressure, the new volume is 0.037 cubic meters. So that's an example of using a general gas equation. P1V1 over T1 equals P2V2 over T2. So I'll do some more examples on this for a bit of practice. The other one that we're going to be using is called the ideal gas law. So far we've been dealing with pressure, volume and temperature. But this new one, the ideal gas law, we're allowed to calculate the mass of gas as well. So we can use pressure, volume and temperature and this new gas law to work out the mass of gas. And here it is, PV, which is pressure and volume, equals mRT, M being mass, T being temperature, and R being this gas constant. So PV is pressure in bar or Pascal, V is volume, T is temperature, cubic meters in Kelvin, M is the mass in kilograms, and R is the ideal gas constant. It's different for every gas as the measure of how energy and temperature are related. So it's a set constant for whatever gas we're dealing with. So PV equals mRT. Obviously, we'll rearrange this to find the mass in the examples. So that's just an introduction to the formula we're going to be using. PV equals mRT, and if I go back, P1V1 over T1 equals P2V2 over T2. The next couple of videos will be some examples using these equations, and obviously they will bring an assignment sooner or later. So have a bit of practice, and over and out.